Hello, in this example we are going to be doing a hypothesis test for a population proportion. So instead of running a test statistic using the t-value and the t-distribution, we are going to be using the z-value and the normal distribution. So let's get started. And so what we have here is the setup is the Whirlpool Appliance Company has a customer service department that handles customer questions and complaints. They are well equipped to handle email and phone inquiries, but less so for letters. The department manager estimates that 15% of letter writers have not obtained a satisfactory response within 30 days of time when their letter is received. The manager's goal is to reduce this value by at least half, so that is 7.5% or less. To do so, she changes the process for responding to letter writers. With this new process in place, the manager has tracked 400 letter writers and found only 23 of them are classified as unsatisfied after a 30-day period. So our question, is there statistical evidence that the proportion of unsatisfied customers has decreased to 7.5 or less? And the second one is at the level of significance of 5%, so a p-value of 0.05, can we confidently say the new proportion of unsatisfied customers is below? So we're going to be testing out our hypothesis, and the null hypothesis, the status quo, says that the proportion of people that are unhappy is greater than or equal to 7.5%, and our alternative hypothesis is that it's going to be less than 7.5%. Okay, so let's go into our data. And what we are going to do is we are going to do a one-tailed analysis because we only want to know on one side of our curve. And what we're going to be looking at is we're going to be doing a less than because we have 7.5% and we want to know if we are less than 0.7075%. And you can see right here we've got listed out. If it's one-tailed and it's less than, we're going to be using the normal.s.dist. Which remember, so if I drew my little normal curve here and I have my line, less than will just be the normal. To get anything greater than, you would have to do 100% minus what's going on there, and that would be our one-tailed greater than. And then if we're doing a two-tailed, so not equal to that value, we've got this mess here. So let us start going through. And the first thing that I want to do is I do want to put in range names for these ones right here. So insert, formulas, create from selection. We want to pick the left column, hit OK. I can't range name all of these and these together because since some of the names are equivalent, what will happen is it'll start making these, and then when it gets to here it goes, do you want me to replace this? And so you'd end up with just the sample size here at the end having them. I want this one right here to have the range names in it because this is where a lot of our equations are going to be from. We're just going to pull them down. Okay, so the data that we have is we have a sample size of 400 and we have 23 unsatisfied customers. So let's go and calculate out how many satisfied customers we have. So we've got 400 and we're going to subtract 23 from them. That tells us we have 377 satisfied customers. That is pretty good. In fact, if we just quickly take a look at things, 23 divided by 400, oh, look at that. We have less than 6%. So that's 5.75% of unsatisfied customers, which just based on the mean, just based on the pure data, it's telling me that it seems that the number is lower than that 7.5, but we can't just say that it's statistically significant, that it's within that level. So let's go over here and start putting it together. So our sample size is going to be 400. We're going to define that right from there. And so the number of, let's just expand this out. So number with property interest. with property of interest? Well, the property of interest is the unsatisfied customers, because that's what we're tracking. So we're just going to come over here and we're going to say B4. And so those are our unsatisfied customers. Our sample proportion, we actually already did that. That's going to be our sample size. In fact, I will grab that here. In fact, let's quickly, we'll range name these. It'll end up overwriting the sample size, but that's fine. Replace existing definition, yeah, that's fine. So we'll just quickly come over here, and so that's our sample size, that's fine. B4, this will be our number of unsatisfied customers, that's our property of interest. So our sample proportion is going to be our number of unsatisfied customers divided by our sample size. Another reason that I like range names, it's easier on the teaching side to go, okay, that's what these are. I think it's also easier when you go back to review these, because you can click on that and go, oh yeah, that's exactly what the equation is. It's a lot easier than trying to piece it together, especially once we start getting into here where we've got the statistics equations and you're trying to tie them back to your notes. So let's find the standard error of our proportion. So how do we do that? We're going to go to our square root, and we are going to take, now we've got a fraction here, so we're going to have the square root of our hypothesized proportion. And so our hypothesized proportion is what we're testing against. So we are saying that it's going to be 7.5 or lower. So here is our hypothesized proportion. We're going to take that and we're going to multiply that by what's not our hypothetical proportion. So 1 minus our hypothesized proportion, and then we are going to divide that by the sample size. And actually, we'll grab that sample size since that number is in there. And then we'll close that up. So we've got our proportion times 1 minus our proportion times the sample size. And so that gives us a standard error of the proportion of 0.0132. Okay, so now we have our test value. Now we are using a population and not a mean. Since we're looking at not a population, we're looking at a proportion, not a mean. That's why we're using the normal distribution instead of the t-distribution, which means that we need to calculate out a z-value. And remember, the z-value is a standardized value, so what are we going to do? We are going to take the sample proportion subtracted from the hypothesized proportion and divide it by the standard error of the proportion. And remember, that's what normalizes everything, so we're not worrying about units. So our sample proportion, we are going to subtract from that our hypothesis proportion. And then since this is going to be in the numerator, we want to put the parentheses around there. And then we're going to divide it by our standard error. And we pluck that out, and that gives us a z-value of negative 1.32. Okay, and so now the last thing is we need to calculate out what the p-value is. So the p-value we're going to get from the normal distribution. So equals norm.dist, and we're doing it of the standard. Remember that S is for the standard curve, so the normalized curve. So we want to know our p-value, where our p-value is going to be that test statistic, and we want it to be cumulative, because if we put 0, what it's going to do is it's going to tell us what the p-value for just that one spot would be, what the distribution for that one spot is. We want everything from the end all the way to where we're at. And so we go to calculate that out. We get a p-value of 0.092%. So what does this tell us? This tells us that we can say that there's statistical evidence at the 10% level, because that would be a p-value 0.1. So there's statistical, let's try that again. So there's statistical difference at the 10% level, significance level. Not at the 5%, not at the 1%. And so remember, those are typical standards, 1% or 0.01, 0.05, and 0.1. So a p-value of 0.092 puts it within the 10% significance level. There's evidence to support the manager's claim that the proportion of unsatisfied letter writers is 7.5% or less. So there's some support. There's not overwhelming support, which if you would have been at a 0.05 or even better a 0.01, that would have been no question at all. But there is statistical significance that things have changed. Okay, so question 2, at what significance level of 5% can we confidently say the new proportion of unsatisfied customers is below? So what we're going to do is we're going to kind of go through this, and we're going to use goal-seek to calculate out where we need to go to get a p-value of 0.05. And so what we're going to have to do is we're going to have to fill in some stuff, and what we're going to do is, well, we're going to still say that it's a one-tailed, because we're going to do the same test. And in fact, what I'm going to do, since this video is getting long, I'm going to pause it right here. We're going to come back and we'll do the goal seek for this part.